Hey everyone, so in this lesson we're going to talk about solving radical equations. Now this is a very popular topic on the Regents exam. It's 2 lessons because there are 2 different levels that you can have for this topic. So definitely pay attention and take it slow with this lesson, and as I always suggest, once I do a question, I always would say, you should pause the video and try to attempt the problem on your own to see if you can get the answer right. So let's start with the do now. It asks you, what happens when you square rad 3? So you guys should take the time and think about the do now on your own, pause the video, and then check your answer. So when you square rad 3, technically you're just multiplying these out twice. You would get rad 9, square root of 9, and the square root of 9 is 3. If you remember in the last lesson we talked about this, when you multiply a square root by itself, you end up getting the inside. So if I square rad 7, what's really happening is the 2 and the square root are canceling out, and you end up just getting the inside. And this is because the index of this radical is 2. Remember, there's a little 2 there. So what conclusion can you state? When you square a square root, the radicand is the result. Okay, so I will fill in the steps when we do a problem. So step 1 is to isolate the radical, which that means to get the square root by itself. So you're going to add over this 3 so that it becomes by itself. So you're going to isolate means get by itself, the square root. Then what you're going to do is you're going to want to get rid of the square root. So you're going to square both sides. So you're going to square. You want to do this because you want to release the x from the inside of the square root. And then you're going to solve and check your answer. So I would solve and I would get x equals 11. Now it's very, very, very important that you check your answer. And the reason being is because we need to remember that square roots cannot have negatives inside of them. And if that happens, the answer doesn't work and you end up getting something called an extraneous solution. So the proper way to check your answer is like old school, where you would write the original problem and you'd plug in substitute for x. So 11 minus 2 is 9. Square root of 9 is 3 minus 3. 0 equals 0. That's the legitimate way to check your answer, is to substitute the variable, the answer you got, back into the problem. But there is a trick that you can do, and I will post a calculator video on how to do this. But basically what you would do is take your original problem here. Well, let me erase. Oh well. You would type the whole right side into y1, or left side, and the right side into y2, and your y equals area. And then if you look at the table in the calculator, you can see that when you look at 11, the 2 sides match. You should see 0 equals 0. Okay, so that's the check for the calculator. So I suggest pausing the video and trying this on your own now. And if you have already tried it, you can unpause it. So first step is to isolate the square root. So add over the 2. You get 9. Second step, square both sides. The goal, remember, to do this is to cancel out the square root. 9 squared is 81. Next step, subtract 6, because you're going to start to solve for x. 3x would equal 81 minus 6 is 75. Divide by 3, and x would equal 25. And you're going to check your answer before you box it off. Okay? Again, I would suggest put this into y1, put this into y2, look at the table, make sure they match. But I'll do one more legitimate check for you guys. So I'm going to plug in 25. And then minus 2 is on the outside. 3 times 25 is 75 plus 6 minus 2. This is the square root of 81 minus 2, 9 minus 2, 7, and that does equal the other 7, so this works. Okay. Again, like I've been saying, you should try to pause the video right now and try this problem on your own. So isolate the square root equals -1. Now, if you notice, I have a square root equal to a negative number. Already this is a problem, and you could technically stop here and say there's no solution to this answer because the square root will never give you a negative. But if you didn't realize that, go ahead and go forward with the problem. These will cancel out. You'd end up getting x minus 2 equals 1. Okay. Solve. You'd end up getting 3. And you would check your answer. Again, type this into y1, this into y2, look at your table, see if they match. That's the shortcut way to check. You don't ever have to show your check. This is just me showing you guys. 3 minus 2 is -1. Nope, it's just 1. I'm sorry. Square root of 1 is 1. 1 plus 6 is 7, which does not equal 5. So this doesn't work. So we would say no solution because we only got 1x and that 1x doesn't work. And we classified this as something. It's classified as an extraneous solution. I think of the word extra in this. It's an extra solution. It doesn't work. It's just extra. So that's how you classify a solution that doesn't work for a radical equation. So isolate the radical. There's nothing here to get rid of, and then you're going to usually square it. But if you notice in this problem, it's a cubed root. So it works out the same way. You would just cube both sides. That would cancel out the cube root, and you end up getting 4x plus 1 equals 125. Isolate the x now, because you're solving. 4x equals 124. Divide by 4. X equals 31, and you're going to check. You're going to plug this original side into y1, this original side into y2, look at the table, and you will see that they work. Again, I'll post a calculator video on this, so check that out. All right, same idea here. I suggest you pause the video and try this one on your own. If you've already paused it and tried it on your own, you can watch what I'm going to do here. I'm going to fifth both sides so that I cancel out my square root, or my fifth root, I'm sorry. 2 to the 5th power is 32. I'll add this over. 3x equals 33. Divide by 3. X equals 11. You're going to check your answer, plug this into y1, plug this into y2, and you will see that they both equal. Again, you could also choose to just plug in. But yeah. Okay. Now the next one is going to take some time because if you notice, this is the first problem we have where there are 2 letters here. There's a y on both sides. Okay, so we're going to subtract 10 to isolate the square root. You get y plus 2 equals y minus 10. Then you're going to square both sides. These will cancel. You'll end up getting y plus 2. And look what's going on here, people. This problem actually needs a lot of space, so if you need extra paper, you should definitely get that out. You're going to have to box method here. So y squared minus 10y minus 10y plus 100. So I end up getting y squared minus 20y plus 100. And then I just drop this down. Now if you remember from Algebra 1, when you have a squared, in order to solve it, it needs to be equal to 0. So you have to subtract over the y and subtract over the 2 to make this equal to 0. This will end up getting you negative 21y plus 98. Now this should look very familiar to you. This is just an AM method setup. adding to 21, negative 21, and multiplying to 98. So you're going to think to yourself, what are the factors of 98 that add to negative 21? And that would be 14 and 7 when you guys look at your table. I'm going to make them both negative because they need to add to a negative 21. Now, if you notice, I just teed off. So if you remember this from Algebra 1, you would add 7 to both sides. You get y equals 7. Then you set the other side equal to 0. Add 14 to both sides. You end up getting y equals 14. Now, usually, when there are two answers with this, one of them doesn't work. But we're going to check by either plugging them in or using the calculator trick. And I think this is the easiest way to do this, is with the calculator trick. So what I mean is that I would type into my calculator this into y1 and this into y2. I would use x's, of course, for the y's because there's no y letter. You're going to look at your table and you're going to see that 7, the y1 and y2 columns don't match. So you're going to end up rejecting this, and you're going to write reject because this doesn't satisfy the original equation, because this is an extraneous solution. Again, you will not understand what I'm talking about if you don't do that whole trick with the y1 and the y2 deal. And y equals 14 is your answer. You will also see the answer written like this with these set notation brackets around it. This is your solution set, okay? All right, and then we only have 4 more problems here. I do suggest, of course, that you try these on your own before you watch me do them. The more practice you have, the better, obviously. So let's go ahead and start off with the next one. The goal here, of course, to start off is to isolate the radical. So I'm going to subtract my 1 over to this side here. I'll end up getting x minus 1 equals the square root of x plus 5. And then I'm going to square both sides so I can get rid of this square root and I can release that x. This is another situation where you're going to have to do box method, people, because of the binomial on the inside here. Do not make that mistake. Do not distribute this. That is very wrong. Don't do that. You're going to box method this guy here. X squared minus x, and a 1. So you're going to get x squared minus 2x plus 1 equals x plus 5. Now remember, for my last problem, I told you that in Algebra 1 you learned that x squared likes to be equal to 0 so that you can solve it. This is the goal. The goal here is to be able to factor it using AM. Negative 2 and negative 1 make a negative 3x, and 1 minus 5 is negative 4. You're going to go ahead and do add, multiply. You're going to add to negative 3 and you're going to multiply to negative 4. What are your factors that add to 3? Well, that would be 1 and 4. I want a negative 3 though, so I'm going to make the 1 positive and the 4 negative. I'm going to tee off here so that I can add the 4 to either side, and x equals 4. I'm going to set this side equal to 0, and I'm going to subtract 1. Subtract 1, and I'll get x equals negative 1. And now I'm going to check my answers. I'm going to check negative 1 and 4 in the table. I'm going to put this into y1 and this into y2. I'm going to look at my table, and I'm going to check the 2 x values I just got, negative 1 and 4. So take a moment, pause the video, and type those equations into y equals. Then unpause the video, and you can see what's going to happen now. So when you checked, you should have seen that negative 1 did not work, so we're going to write reject. This is an extraneous solution. Sorry, my handwriting is really bad on this iPad. Let's write this a little nicer. You're rejecting because it is an extraneous solution. Extraneous. Okay. And then 4 is your actual answer. All right, moving on. Okay, so this is your first example that you're going to see like this. If you notice, there are 2 in front of the radical. But if you notice, this is connected by multiplication here. So you could divide by 2 to isolate the radical, but when you have multiplication, it's actually easier just to keep the 2 there and square. That rhymes. Keep the 2 there and square. Okay, so basically what will happen is the 2 can distribute into both these. This is allowed because it's over multiplication. So it's become 2 squared, and this is going to square here. It'll cancel out the radical here, and then that'll become a 4, and then you'll end up getting 3 minus x. Distribute this in, you'll end up getting 12 minus 4x. Now we notice we have a squared here, and we know that x squared likes to equal 0 if you've been following along what I've been doing. So I'm going to bring over these guys over here so that I get this side to equal 0. I'll end up getting x squared plus 4x minus 12. And again, I'm going to do AM method. What are your factors of 12 that add to 4? So 12 has 1 and 12, 3 and 4, 6 and 2. This is your pair. You're going to do a positive 6 and a negative 2. Split this down the middle and solve. So I'll add 2 over, x equals 2. Set this side equal to 0, subtract 6 over. You get x equals negative 6. And you're going to check your answers by putting the left side of the original equation, so you're going to put x into y1 and 2 square root of 3 minus x into y2. You're going to look at the table, and you're going to check negative 6 and 2, and you're going to find out that negative 6 does not work, so you're going to reject this one because it's extraneous. And you're going to keep 2. Okay, where am I on this thing? All right, so 2 more. Again, I suggest that you try this on your own and then check your answers. Okay, so I'm going to isolate my radical. I have to subtract this one. I cannot do that whole trick that I did in the last problem because it's not multiplication. You're going to go ahead and square both sides. We're doing this to reduce the radical. We're going to write this out twice. And you're going to end up box methoding this side, or FOIL, whatever you prefer. So you get x squared minus x. This should really be written down there, but of course it's not letting me erase for whatever silly reason. What does this one do? Oh, now it's erasing? Okay. All right, so minus 1, okay. Negative x and then positive 1. These will combine. So you get x squared minus 2x plus 1 equals this side here. Okay, so I'm going to subtract 2x over here and then subtract the 1. These will cancel, become 0. So I'll end up getting x squared minus 4x. These will cancel. Now the goal has been to do AM method, but if you notice there is not a third term here. So do not freak out. You can use another type of factoring method, and that factoring method is GCF. You're going to pull out that GCF and get x minus 4. You're going to tee this off. People always forget about this. X equals 0 is a part of your answer right now. So you're going to check x equals 4 and you're going to check x equals 0 and see which one works, or if both of them work, great. And remember, the way you're going to do this is either plugging in old school and solving, or my suggestion, which is to type the original left side into y1 and the right side into y2 and look at the table and check 0 and 4. And when you do that, you're going to see that 0 doesn't work because the y1 and the y2 don't match, and 4 is your answer. All right, last guy here. This is an easy one. Isolate the radical. You should try this on your own. you end up getting negative 3. Very similar to our last problem, if a radical equals a negative, we know that's not going to work, but we're going to go ahead and solve this just so we can make sure these guys will cancel. So you get 4y equals 12 divided by 4, y equals 3. Check your answer. Either plug in or plug this into y1 and this into y2. When you check 3, you're going to find out, nope, we're going to reject this answer because that was an extraneous answer. So I hope this helped you guys with solving radical equations level 1. The next lesson is level 2, and it's going to be a lot of fun. So I'll see you on that lesson.